Okay, so good evening and also good morning to region of Malaysia. Thanks for coming back to this RoboCup at Home Education Online Challenge 2021 online classroom. Today we have open platform, and today is the third class for this open platform track OP. We will discuss about robot visual perception, and we will have two session that I will introduce after this. So first of all, I'm Jeffrey from RoboCup at Home Education, and together with me today is engineers from Jupiter Robot. So we're glad to be here to show you some basic about robot visual perception. Right, so let me start with some logistic. Okay, so as usual, so we have the meeting link, and if let's say your colleague or your student or whoever still on the way, please inform them to come in, follow the link. As I said just now, we have two sessions today. So the first hour, we will discuss about RGB-D sensing. So basically, I will show you the most popular sensors that we use for our beginner robot platform to show you how to get all this data. Okay, maybe I will start with like, so what kind of okay, please turn off your mic, please. Thank you. Okay, thank you. Right. So for the first session, I will introduce about this RGB-D sensor and then how we are going to get the data, and including like after that we are going to save the data as an example at the end of the first session, which is something similar like take a photo. Okay, right. So that is what you're going to expect for the first half, and then for the second half we are going to talk more about image processing. So once you got all those information from the visual sensor, so what can you do? So we will show you some example because like the time is very limited. We only have 1 hour. So we will show you some example exactly what you can do with the images that you obtain from the sensor. And I will invite our colleague in from Jupiter Robot to show you some actual demonstration. Okay, right? That they will use the actual sensor and capture the data. And then after that, we'll show you some application. Cool application, for example, like face recognition, face detection, color tracking, and so on. Okay, right. So as usual as well, so I'm going to show you like, the three links. So I hope by now you already know, but just in case any newcomer today, so I will show you like the place where you can get all the information. So first thing first is like, oops. Okay, so oh yeah, I forgot. I'm using the PDF version. Okay, so just in case you are new to this session, so you can actually find the one that you can see in front of you, the PowerPoint slide over here at our website. So there's a link on top you can find. So like today's PDF is over here. And also, this is the link to join the class. And also, I have, if you want to know more about like the course materials and so on, so it's on the second and third link. Okay. Okay, I get this thing away. So. Okay, right. Okay, so this is the materials, and also I would like to review the assignment after this, but I'm going to do it later. Okay. Okay, so then I have, so this is where you can get the file, and also for the video I already uploaded, so you can find the video just in case you want to find the video for speech interaction or the first how to install your software and so on. You can refer to the video over here. Okay, right, and then you can get the PDF out like this. So I'm showing directly. And lastly, like, yeah, this is the class group. So you please join if, let's say, you would like to interact with us after this. Okay, so these are all the material. Okay, so I'm going back here. Okay, so before I start, just a final reminder, please refrain from turn on your microphone and also your camera throughout the whole session unless you are told to do so, which is normally we only do that during the last interaction session. Okay, so for all the time, please turn off your microphone and also your camera. Okay, so here we will start the session today. Right, so for today's online class, we are going to do the visual perception, which is you're going to use a camera or some sensors that list down over here, and then you're going to capture some images so that we can discuss how to do the processing. So there are a few hardware that you might need to prepare. So for example, like if you have a webcam, which is now normally for most of the laptop, come with the built-in webcam, okay, or USB camera. But due to the different type of camera attached on the laptop, so we need to see whether if you can able to find the appropriate driver to make it work. And this we will discuss more later on. Okay. And then the second one is this is what we recommended for our development is this RGB-D sensor. So RGB-D sensor in a very simple form is like we have something very similar like the USB camera for the RGB. RGB is for the color sensor. Then we have a depth sensor, which is the distance sensor. Okay, so a combination of these two, then we get this what we call the RGB-D sensor. RGB-D sensor now become very popular in robotics and also for computer vision because we got like very rich data in terms of color and also in terms of distance sensing. So this kind of very rich and also very, how to say, informative data can help us a lot in terms of like for the robot to understand the surrounding. Okay, so previously we used a lot this Microsoft Kinect, which is a very popular, and also this is the device that actually changed the whole landscape of visual perception because like they are the first one that to introduce this concept of RGB-D, which is you have these two kind of data putting together and give a new dimension for robot visual perception. Okay, but unfortunately the old Kinect already like not in production anymore, so you might need to use the newer version, which is the Kinect One, right? But that might require a different type of hardware and so on, which is we'll discuss more after this. Okay, right. And then we have other very similar like Intel RealSense, or you can have, for example, like this one that we use over here a lot for robots, this Obek Astra, which is also the recommended replacement or alternative for Turtlebot 2. And then also we also have the Asus Action Pro Live that you can use, but also like already end of production, which is they come out, have a new version and so on. So this range of sensor belongs to this RGB-D, and if will be nice if let's say you can prepare one of it for our this class. Right? Then of course like you need your laptop, which is to run your either VirtualBox or your dual-boot system that we need our development environment that we discussed in the first class. Okay, so for the software, it's the same environment that we already installed in the first class. Okay. Okay, so extension from what I said just now. So to let you know, like for robot vision sensor is pretty much similar to computer vision, that we use not just the color but also the distance sensor, and we put them together. So you can see like okay, for example, we start with the simpler one. Okay, on the lower left hand side we have this is a Logitech webcam. So this one very popular, I think, like you know this thing that the interface is USB, so you can plug in USB interface to your laptop and you can get the images for your webcam application. And for people that use Raspberry Pi, so this is a Raspberry Pi camera that also is very popular for Raspberry Pi scales of development that to give the camera input. Okay, and for the Kinect, this is the Kinect, okay, that I mentioned just now. You can go to the link for more specification, which is I have some specification that I will introduce after this, and you can see like it is actually come with a color sensor and also a pair of infrared depth sensor with emitter, and also this is the receiver. So you have the IR emitter and receiver. So it is actually measure the distance by using optics, but it is using the IR, which is the infrared. Then for this tube motor is actually to like control the orientation. Sorry, not the orientation. The pitch of the camera, and also it also come with this microphone array that we have discussed last week, that you can use it for your sound localization. Okay, then for robotics, usually for navigation tasks, we will use this 2D laser rangefinder, which is like 2D means under one plane, and then it have the laser that give you the distance, right? The distance throughout the whole plane. And this laser range, because it's using laser as compared to the IR over here, so the range and also the intensity is relatively higher. So which means this range of sensor can actually give you a bigger range. So you can actually measure the distance in the longer distance. And for example, like autonomous car, they usually will use this type, which is eventually they have the 3D type, which is like this, and then you have the LiDAR sensor. Okay, they call it the LiDAR sensor. Okay, you have the 3D form of this laser sensor, and then in a very much bigger range. For example, like up to 100 meters to like a few hundred meters, and the speed is relatively fast as compared to the lower range sensor. Okay, so you will get some data like this. So this is a 3D laser rangefinder, which will give you what we call the point cloud. Okay, so the point cloud is something that we use to measure or to give you the idea of the 3D shape of the object in front of you. Okay, so we have many types like optical types, camera based, and all this. Ultrasonic. Okay, so we also use ultrasonic if we are not using the laser and so on. Okay, so these are all the sensors that use the optical theory in order for us to either get the information about the color or the distance. Okay, so as we use a lot this Kinect sensor, so I will give you some introduction about the specification. So for this 3D Microsoft Kinect sensor, it comes with a RGB color VGA video camera, and also it paired with a depth sensor, which is using this infrared projector, and it paired with this monochrome CMOS sensor. So one project and one receive, and that's why you can get the distant value. And the resolution is not very high, so it's just a 640 times 480. But for calculation, normally we don't use very high resolution. Okay, we use high resolution for webcam, but usually for image processing and so on, we don't use that much of, I mean, like that big resolution of image, because like we want to speed up the processing. And you can see like the frame per second is 30 frame per second, which is like in every second it has 30 frame. Okay, so if let's say for all the frame you need to do 640 times 480 pixel of calculation, then yeah, the amount can be very big. Let's say you increase the resolution. And another point that very interesting about this Kinect sensor is like you can see the effective sensing range. So because like initially it is designed for game, your game console application. So for example, like you have your TV and also your Xbox in front here, and the range that for sensing is somewhere in between. Okay, so if you look from here, it's about 1.2 meters to 3.5 meters. Okay, the blue color one is the most effective one. but also you can see like the maximum one is from 0.8 to 4 meters. Okay, so it is a very comfortable range for between a human height, so it's 1.8 height. That the distance with the Xbox, this distance is actually also very similar for the range for the robot to interact with human. Okay, so this range is very comfortable for us to use it in our service robot, because like we want to have this range for the robot to be able to interact with the human, right? So, and the interaction normally happen within this range. Okay, but one thing that you need to take note is like anything below 0.8, which means the sensor will not give you very accurate or even don't give you any data somewhere lower than 0.8 meters. So you can assume the sensor is actually blind if, let's say, your object is actually very near to the front of the sensor. So this is something that you might need to take care when you are designing your application. Okay, but actually we have quite a variation of this what we call the more nearer range for RGB-D sensor. Like the RealSense got a big range of near RGB-D sensor that you can actually choose from. Okay, but this is a more general one that we use for our Kinect, and I think similar range for the Astra sensor that we use for the demonstration after this. Okay, so this is the effective sensing range. Right. Oh, sorry. Okay. Then, in order to measure the distance, we are using the how to say physical phenomena of the lights. So, which means the light will actually get reflected from the object and come back to the receiver. So we have a transmitter, okay, which is in front of you. It will transmit the light, and then this light will get reflected by the object and then come back to the receiver. Okay, so if you follow the distance and also the speed, so we have the speed, we have the time difference, which is the time difference between the transmitter transmit and also the time the receiver receive. So the length is basically half, okay, so or you divide, because like it's to and fro, so of the speed times the change of time, okay, the rate of time, the change of time, okay, and over here we use this time of flight, TOF. So it's for the laser beam emit from the transmitter, hit the object and return to the receiver. So this is what we call the time of flight. Okay, so this is basically the concept of how we use light to measure the distance. Okay, then we use again the optic characteristic in order to get the color. Okay, we know how we can see color is because like every different surface, they actually reflect the different color, okay, and depends on how intense the color or the light being reflected, so we can see the color differently of any kind of the surface, right? So how we actually design a sensor to actually capture this color information. So in a very simple term, because now we have very sophisticated system to do this color imaging or color sensing and so on, but in a very simple term or in a very simple concept, okay, this is how it works. So how a camera sensor works. So we have the imaging elements, which is it actually sensitive to light. So the light intensity will be converted to electric signal by this imaging element. So the imaging element have this characteristic that will change the light intensity to electrical signal. And normally we can find like in a CCD or CMOS. I think like when you buy cameras, yeah, this is the terms that always brought up, like the charge coupled device or complementary metal oxide semiconductor and so on. Okay, so but these two work very much similar. They have some difference, but the concept is very much similar. So you can see, for example, like this is the imaging element. Okay, the lights will hit the element, and then the element will generate the electric signal. And you can see like the arrangement is actually like this. Okay, so for example, like you try to imagine this is all the photodiode that you have a different color filter. Okay, So the color filter will consist of red, blue, and red, green, and blue. So that's why you have the term called RGB, and D is for distance, so RGB. So for all the pixel, it will look like this. So it will actually try to filter out the rest of the color, so to see how much red, how much green, and how much blue on a single pixel. Okay, so how much of that intensity, and it is measured by pixel, and pixel value is 256 level, so it's 0 to 255 8p. Okay, I'm not going to explain more. If you would like to know, you can go to this link and have a look, and there are many resources to tell you about this color sensing. Okay, but now I just introduced as a simple concept for you to understand. Okay, then for our virtual perception challenges in service robot, because like we are building service robot, or over here we are discussing about service robot development. So for us, we use this virtual perception for certain function or certain objective in our development. So for example, I take the scenario from RoboCup at home. So you can see I put up like A is the typical area. So this is the typical area in RoboCup at home that the robot have to do some work or some tasks inside this environment. So you can see like the environment is very much similar like our house. You have the very house environment, a very flat surface, and then very colorful, and also a lot of obstacle. Like you have a lot of furniture, and you have not just a static obstacle, you have the dynamics, which is like human is walking inside, and you have pets and so on. And also you have moving object, other moving object as well in the home environment. So you can see the whole environment is very colorful, very bright, and also very dark. For some places, for example, like under the table, under the chair, and so on, they can be suddenly become very dark, and a lot of shadow, especially you have different lighting. Okay, like in your house or in your home, maybe like in your living room and also in your study room, you have different color of, like the light is different, like yellow light and white light, fluorescent light, and so on. So it actually gives you different brightness, and also it creates a lot of different intensity of shadow that will make the whole place very complicated for visual perception. Okay, so that is actually very challenging for us when we want to do visual perception in this at-home environment. And the second thing, the challenge is like always we are interested on all those objects which is also very colorful. You can see like all the packaging of the things, the object in the home environment is relatively colorful as compared to our test object. For example, like normally we will use like a cube or cylinder, which is have only like a monocolor, but in real life, we actually deal with like the label, which is have a different kind of wording, different character of writing, and also different pattern and so on. So you can see these are all the challenges when we want to design our visual perception. Okay, right. Okay, so just to give you some idea or some example, exactly how we use our this visual sensor or visual perception in the competition or in real life. So one of the tasks is for speech person recognition and speech and person recognition. So in this task, we need to use the visual material information in order to recognize the people around. Okay, so this is a real task in the competition that we need to recognize, or how to say, to detect the person and also to recognize who are these people. So for example, over here, so this is our one of the result from our team. Okay, so it need to find like who is the operator. Operator is the one that robot know. The one in blue and red is the people that the robot don't know before this. So it's like stranger, but on top of that, the robot are required to separate between like male and female. So male is like in blue and female is red. Okay, so you can see even just to find people, not just only to detect, but you need to like recognize like who is these people. If the person is not someone that you know, the robot, then you also need to identify whether it's a male or female. So that is the challenges. So how you want to get the image information in order to figure out all this answer. So that is the challenges for your visual perception. Okay, then the second task, like in this sorting grocery. So we have all this grocery that you need to how to say, sort out. So you like someone actually like did shopping and then brought back like a few bags of grocery. So the robot need to like sort out the grocery. So you need to identify what kind of grocery, what are their groups, what are their how to say, category, and then they have to put in the same group, okay, in the cabinet and so on. So you can see these are all very challenging in terms of visual perception. Okay, right. So we come to the times that so we already like taught all the background and also the theory part. So now let's move to the practical part. Okay, so in order to start with robot vision with ROS, so we need to know a few things. So like, of course, you need to have your ROS development environment, which you already have, I assume. Then a few library and also driver that you need to know. I mean, I would like to introduce here. So for example, there are a few that very important for you to know. So for example, this OpenNI2, OpenKinect, PLC. So these are all the library that will interface with your sensor and also to help you to sort out your data. Okay, so for example, this OpenNI2 and OpenKinect. So these are the two, how to say, library and also driver that help you to run or to activate or to use your camera sensor. For example, like if you use the Kinect, then you need this OpenKinect and also this OpenNI2 in order to actually get the sensor to recognize certain, for example, like get the skeleton and so on. Okay, so these are the things. But if you would like to know more, you can go and read from the website. But basically, these are all the drivers and also the library already like installed in your development environment. So no need to worry about that. It's already inside in your ROS environment. Okay. Then for this PCL, which is a point cloud library, it's also part of ROS that help you to process point cloud. So point cloud, as I said just now, so you are using the depth sensor, then you can find a lot of point in the space and how to actually process this point. So we can use this point cloud library to help you to like do a pre-processing in order for you to have a very clean and nice data for your analysis later on. Okay. Then you need to have a few library for your analysis, okay, for your image processing. So one very popular one is this OpenCV, which is Open Computer Vision. So this one is by Intel, and then it's very, very popular for image processing. So you can head to the website to see more, and it actually compile a big library of all the fundamental image processing technique that we use heavily in our development. Okay, I will introduce this OpenCV by showing you some example in ROS. So a group of people in ROS, they actually wrap this some of the very popular library in OpenCV in application form, okay, and put it in to wrap it as a ROS application that you can execute it directly. Okay, so without actually need to do a lot of transformation between OpenCV and ROS and so on, because like OpenCV actually exists even before ROS, so it already has its own standards and also like protocol in the data format and so on. So when you want to work OpenCV with ROS, you need some conversion like the CB bridge and so on. But if you use this OpenCV apps, which is a application library for ROS, this process have been like taken care. So all you need to do is like you need to see like what kind of application and how you can use it. Okay, which is I'm going to show you right now. Okay, so let me open up this page to show you. Okay, so if you click on that link, okay, sorry. If you click on that link, this link, you come to this page, which is in ROS Wiki, right? And so far, this package have been developed since the Indigo, ROS Indigo version, and then it have been like maintained and updated for kinetic and also for melodic. So far until melodics, everything will fine, but neotic maybe is not ready yet. Okay, so for melodic it's still okay. So for our version 18 Ubuntu and ROS melodic, this library work perfectly fine. Okay, I want to introduce like what kind of content inside here. So you can read like all the details over here. Okay, but there are a few things that important. For example, like a few class of analysis to do. For example, like this age detection. Okay, so for you to do age detection, something like this. So for example, like to get the outline of certain object and so on. This whole line, this one is very popular. Okay, so if you are working on computer vision or OpenCV, these are the fundamental basic features that you might require, and you can use this for your convenience. Okay, this one for the circle. Then the second group of function is this structural analysis node. Okay, structural analysis node. Maybe if you are not using computer vision, you might not really know. For example, like to get the contour. So this is a contour and so on. For example, like this one, to find the contour and so on. So these are the things that you can use. And today we will show you this one, which is more relevant and more direct to our application in service robot, which is this people and face detection nodes. So we actually use this library and also these apps for you to do face detection, for example, and it is using this cascaded classifier to find the face, right? Okay, so like this face detection, and also it also comes with a very simple face recognition features that not just to detect the face, but also you can make the system to learn several faces of the same person in order to recognize or memorize that person. Okay, so you can try, and there are ways to make your learning, which is later on during demo time we will show you in detail how this thing works. Okay, so this is like the face recognition, and not just only the face, but also people detection, which is you detect the whole body, so you can get things like this, right? Then after that, you have this like motion analysis node. This one is good when you want to use your image processing in order to track certain moving object. So for example, like a moving face or moving object. Okay, so it got this like good features track and so on, that you can actually track certain features of certain thing, and for your tracking purposes by image. And later on, we will show you the example of this cam shift. This cam shift is using the color information in order for you to track certain object. Okay, certain color. Okay, certain color. This is using, and also this IK flow. IK flow is for you to track the features. Okay, and so on. Right. Okay, and so on. There are many other things like object segmentation. This one will be useful when you do like you want to get the shape of the object and so on. Okay, something like this. Right. So these are a few. So you can go through this list and see what are inside this library that will be useful for you. Okay, so everything already like nicely packed in the ROS application form that you can use directly. Okay, oops. All right, so let me go back to the slide. Okay. Okay, so this one that we will show you more later after this. Then the first thing before you start anything, you need to set up your camera. Okay, so whether you're using a USB camera or you are using an RGB-D sensor, you need to set up a camera. So over here, we take example using the Astra sensor to show you. But if let's say now you have a USB camera, which is normally you should have in your laptop, you can try to see if you're able to make it work with your VirtualBox or your robot, which is your Linux driver. Sometimes might be not so straightforward, but if let's say your camera are quite, how to say, standard, not those very fancy webcam, like a very standard USB or webcam with the USB interface, you should be able to run it with the USB cam driver by ROS. So if you go to this link, you can find the driver for your USB cam. You can try this, okay? So it might work. Okay. Most of the time, it should work. And for the RGB-D one, like for us, we use Astria, so you can use this. So just in case you're using like Intel RealSense and so on, so you can find the driver in the ROS Wiki. Okay, and also over here, like I would like to take note, like a lot of time you might need more than one sensor. Okay, and how to actually interface more than like two similar sensor in order for you to have appropriate image, the topic, so that you can do your processing. We use this multi-Astria as an example. So if let's say you have two Astria, you plug into your laptop, and then how to differentiate them. So we show you some examples. So just in case you have two similar one, maybe not Astria, you may want to refer to how we do it in order to like differentiate between those two sensors. Yeah, because most of the cases we use like more than one sensor for our robots. For example, like we use one for the navigation and another one for the visual perception in our case. Okay, so we use the ID to make it, to differentiate it. And how to change it is like if you open up this launch file, then that is where we actually input the ID. Okay, so now demo time. I'm going to explain this demo first, then I will show you the demonstration. Okay, so first is like we need to bring up. So bring up is actually to how to say, to launch your sensor and also to make your sensor transfer, I mean like get the data and also input the data into the topic. Okay, so once you launch, then you start to receive the data from the sensor. So once you have the sensor, then you can use this command like the image view in ROS to display whether your RGB data or your depth images using this image view package. Okay, and also I list down all the way. If let's say you're using a USB camera that you only have color data, then this is the line that you need to execute in order to get. And if you're using Astria, so this is how you can display the RGB and also the depth data in a black and white image to show the depth of the data. Okay. And for multiple, so for example, like you have more than one Astria, then for multiple, we actually change the camera topic to become camera top for the second camera on top. And this is how you can get the images. Okay, so now let me show you the demonstration. Okay, so let me put this aside. Okay, then I will bring in my Okay. So first thing first, what you need to do is you need to launch. Okay, so let me put this in a bit. Okay. All right. Okay. So first thing you need to do is you need to launch. So for me, because I connect to my robot, so on my robot we have two Astria sensors. So I use this. Oh, sorry. On RC, Vision, and then multi. Okay, but if you're using a USB camera, you just need to launch this one. Okay, you don't need to run all, you just need to run the one that appropriate for your sensor or your camera. Okay, so if nothing red come out means everything is okay. So I already launched, but you want to know like what kind of data I actually obtain. So let me show you from here. So for Astria, so I can show you like, for example, I run this. This, space this. make sure everything okay. Do I have the, oops, I think something wrong. Just give me a second. Oh yeah. Okay, nothing wrong. It's okay. It's okay. Okay, so I have the image over here. So just to show you like my hand. Okay. So I have my RGB. So this is my RGB information in the frame that I show in image view windows. Okay, so as a comparison, I also show you what the depth sensor look, the depth image look like. Okay. Okay, so I take another one. I paste, but I just realized that it have the same name, so I need to change the name of the node. Okay, so let me say a new name. Okay, okay. Don't worry about the name. Okay, it's just so that I can run both together. Okay, so you can see like as a comparison, this is the RGB data, and this is the depth information. So you can see like the nearer one will become like black, and then the further one become like white. So this is how the information being visualized using this image raw. And for the RGB, then you get the color information. So it looks like a picture. Okay. So from here, what you can do, okay, you can do the first application, okay, which is to save this, and you will get something like take a photo. Okay. So like this. So for example, like now, I want to take this photo. So what I do, I just need to run this. Okay. And you can see like this one is one of the function in our example code repository. So I can copy this, and then I just come here, paste this. Okay, it's a Python code. So I run this, and I got my image. Okay, so you can see it saved the image. And where is this image? Okay, so because I run at the home, so it always appear in the current folder. So where's the current folder? So here is the home direct. I mean like home, we run it at this place. So it appear here. So I have the image here. Yeah, this one. Okay, so I got this, which is the same as this one. Oh yeah, maybe you can see like the height is different. Okay, just to show you why it's different. So this one is my lower Astrea, and this one is taken from my top Astrea. Okay, so that's why they look a bit different. Okay, but you got the idea. Okay, because I have two Astrea, so that's why I can have a different view from different camera. Okay, so this is how you take the photo, or you run the image. Sorry, you run the sensor, then you can save the data as your image. And this is basically very similar like we take a photo, right? So this is the first ever application that you can do with your image sensor. Then actually in our example, we actually have another version which is use take photo sub. Okay, what is this take photo sub? So let me delete off this to show you what is this different. So this, okay, I would like to explain this is because like this will be your first assignment for today. So I will explain this. So I have prepared two versions of this take photo. One is the one that after you hit the enter, you run the node, you will straight away capture. Okay, but the second one is with a subscriber. So it's actually subscribed to a topic that you need to feed a data into this topic in order for it to okay, I cannot. Okay, in order for it to take the photo. So for example, like I already execute this, but there isn't any photo appear here. It's because like it's still waiting. It's still waiting for your command, which is this one. Okay, so if I run this, you can see like what I do over here is like I publish. Okay, so maybe this one, the copy is not so. paste here. So I copy, I publish into this take photo topic. Okay, okay, something like this. So I publish this take photo data into this take photo topic that it is subscribed by the node, so that when every time it got this take photo data, then it will only capture the image. Okay, so if I run this, you can see the image appear. Okay, so this -1 will give you like a latch for 3 seconds, then it will release. Okay, so it's like you publish this data, then it will start to take photo. So you can see like I got the image again here. So the photo is captured. Okay, so your assignment today is actually try to combine these features with your voice command previous work. Okay, I will explain after this in your assignment, but this is just for you to exercise so that you know how to actually combine whatever that you learned today with whatever that you have learned last week, which is the speech recognition. So if you combine the speech recognition with this one, then you will have something what we call the take photo by voice command. So it is kind of like very practical things that you will do for your robots. For example, like you ask the robot, please take a photo of us, then the photo will start to, like the robot will start to take a photo of you. Okay, so by using voice command. So this is how you can implement this idea. All right. And where to find the photo? Usually, like if let's say you run this code, it depends on where you run. If you run your Python code over here, which is at the home directory, then you will find your image at the home directory. If let's say you are run somewhere in other folder, then your image will be saved in that particular folder. Okay, so just in case you cannot find your photo, so it actually follow where you execute this Python file. Okay, so that's much for this first hour. Okay, I hope you understand. So now let's look at the assignment. Okay, so for today's first assignment, okay, so over here, right. Okay, it takes a long time. Okay, right. So for the first assignment for today is like, okay, of course, first you need to set up your camera system for development. So whether, even if you're using your webcam, you can still do this, okay? Because we are not using any depth information. We just need the RGB for you to take the photo. So you need to set up your camera system in ROS, okay? So this is something that you can work out with the example that already given to you. But one thing that you might want to take note is this. Okay, so if you are using this USB, yeah, correct. If you are using this USB cam, okay, after you install this package, which is the driver, then you might realize in your folder or in your directory, you can like raw cd to this USB cam, then you can find this view file. Okay, over here, when we bring up, we straight away launch the USB cam test launch. Okay, but sometimes this might not working, or it might give you some weird output like the pixel is not right or blinking and something. So if let's say that is something that happened, a good idea is like you might want to open up this file, and inside there are actually a few settings that you might need to set. For example, like the pixel size and so on. So just in case that your webcam is operate in a not so standard setting, that you need to have some additional or some adjustment, you can look into this USB cam test launch file and see if, let's say, is any information that you can tune in order to rectify the problem. Okay. Another way is you can run the node without run the launch file. So if you run the node, so if you open up this launch file, you will see like it actually run the node. So if let's say you run the node, it actually run without any additional setting. Okay, that way might how to say work with certain, because like previously I used a few laptops to run with this, and some laptops have problem with the launch file, some laptop have problem with the node file. So it depends on the specification and also the parameters that you need to set for the particular webcam. So this is something that we cannot tell you a solution for everything, because like all your webcam are different. Okay, so you need to look for yourself how to fix your problem, because like you need to know the setting of your webcam. But we show you like this is a place for you to start. Okay, right. So this is one of the notice. I hope it will be useful for you to get your webcam running. Okay, so once you set up your webcam properly, so the next thing is you can verify the output with this raw image view, like how I showed you just now. So you can see whether you can get the image from your webcam in RAW using the image view. Then of course, like you take a photo with voice command, which is like you run the take photo example, but what I want you to practice is try to combine this example with the speech recognition example last week. You can use the LM, okay? You just add the take photo or whatever command that you like for the LM example, speech recognition, and then you add it with this take photo stuff. And by now, I hope you already understand the concept of publish, subscribe, and by now you should know how to actually combine these two, okay? So you can upload this to GitHub, and if you have any problem, we can always discuss, okay? Or you can actually send us inquiry if let's say you face any problem. Okay, so with that, I will complete the first half. So let's move to the second half of the class today.